Well, I guess the interesting opportunities are, for me, they are about an increasing focus on actual performance. Because a lot of stuff up until now has been sort of design standards, but they are, in a sense, theoretical standards, they're desk-based standards. If you want things to actually do what they say in the tin, then you have to assess the performance. So I think that's important from an energy perspective, but it's also clearly important from a health, air quality, environmental perspective as well. So in order to do that, you need to be able to collect that data. You need to be able to monitor buildings, have sensors, whatever, in buildings which understand what they are actually doing. And so I think that's, in a sense, both the challenge and the opportunity. Clearly, technology is enabling us to do that. We have, sensors everywhere. We have everything on our phones and stuff like that. So that's, I think, is the big sort of exciting opportunity to do that at scale. Yes, I mean, the data can be a lot of things. I mean, there's obviously stuff to do with energy data, but energy data always has to be contextualized with other things, with other data, and that includes, energy data is a function of what people are doing in terms of their temperature and their heating and how often they're using it and so on. But that, when you're doing temperature and you're probably doing relative humidity, it's not very much more of a step to do CO2 and start to look at ventilation and so on. So these things are very much interlinked. You need to sort of understand both sides of the equation in order to get a good picture of what's happening in homes and buildings, how they're being used, how people are perceiving them and experiencing them as buildings. So the collaboration there is, I suppose, it's a bit like the sort of journey that we've been on. So we've been doing monitoring of buildings and developing techniques to do that, getting better accuracy, trying to get it at more scale. As we are scaling up, really, we are going to have to engage with industry to do that. So we, can do 10, 20, 30, maybe 50, maybe 100 houses at a push. But if we want this to be in the thousands, that has to be at an industrial scale. So you need people who can make sensors, who can get them deployed, who can manage those really big data sets. Then that provides an opportunity for government and policy to build on that data, to learn from it, what's working, what isn't working, what should we do differently. But also then, potentially to shift from sort of design-based standards to performance-based standards. And you see little bits of that. I mean, the work we did ended up introducing CO2 sensors in new homes in Scotland, in bedrooms, for example. There was some stuff in the last iteration of UK regs, which are starting to talk about having CO2 sensors. This stuff is all much cheaper and easier. And in terms of the build cost of a building, is really small in comparison. So it becomes much more achievable. I mean, the one thing I'd say is that there is clearly a significant overlap between it's the technological aspect. So the technological aspects of a building fabric and performance and systems and so on, and the behavioural element of it. I'm always hesitant to use the word behavioural. It's not behaviour. It's just people living. I was struck by Dennis's one of Dennis's slides, and he said 10% is behavioural. Actually, it's all behavioural, right? In the sense that you need governments to want to do this. You need designers to want to do it. You need industry to want to do it. All those kind of things. Everybody has to want to do these things. Everybody has to change their behaviour if you want to make these things a reality.